Welcome to the Explainer. Today, we're strapping in for a high-octane cybersecurity bootcamp. We are going to completely demystify the absolute core of operating system security. Consider this your exclusive look right behind the curtain of the cyber world. We'll be taking a structured, really hands-on dive into the exact tools and environments that professionals use every single day to secure networks and test vulnerabilities. Okay, let's dive into this. Have you ever wondered why the world's top cybersecurity defenders, the ethical hackers securing massive enterprise infrastructures, and the most notorious malicious attackers all obsess over the exact same operating system? Seriously, what is it about Linux that makes it the ultimate battlefield for both sides of the modern cyber war? Well, that's exactly what we're going to uncover today. To build your confidence step by step, here's our rapid-fire bootcamp syllabus. We'll start with Module 1, the OS Foundation, followed by Module 2, looking at why Linux is a powerhouse. Then Module 3 covers navigating the file system. In Module 4, we're locking down permissions before jumping into Module 5 to build our Kali sandbox. And finally, we wrap it all up with Module 6, Active Network Reconnaissance. Let's get right to it. Module 1, the Operating System Foundation. Because before we can secure a system, we absolutely have to understand its bedrock. Think of the operating system as the ultimate vital translator. On one side, you have your human commands, right? And on the other, you've got the raw physical hardware. The OS manages the memory, the processes, and every single piece of software. Without this intermediary, your machine is really just a useless brick of disconnected circuits. In cybersecurity, this foundation of trust is exactly where the war is won or lost. Because if a vulnerability exists down at this foundational level, literally all other security measures sitting on top of it can be completely undermined. Now, to really grasp the stakes here, we need to compare the two heavyweights, Windows and Linux. Understanding their differing design philosophies is crucial. Due to its massive market share on desktop computers, Windows is historically a vast, sprawling target for general malware. Traditionally, users often ran with higher privileges by default, meaning a breach could be totally catastrophic. Linux, on the other hand, was born from the open source movement. It's essentially a fortress built by the community, where transparency is the armor. Its code allows for constant public scrutiny, and it enforces a really strict permission model that requires explicit, elevated root privileges for any system-level changes. That drastically isolates and reduces the immediate impact of any malware. Moving on to Module 2, Linux, the cyber powerhouse. Out in the wild, Linux is a true dual-edged sword. On one side, we have the defenders. These are your ethical hackers and sysadmins using Linux to build incredibly secure network infrastructures, run deep forensic analyses, and conduct penetration tests to patch vulnerabilities before they can be exploited. But on the exact same battlefield, attackers leverage that identical command line power. They use its flexibility to automate exploits, script massive global attacks, and dig into kernel misconfigurations. The tools themselves, completely morally neutral. The only difference is the intent of the person typing at the keyboard. All right, Module 3, Navigating the File System. Let's map out the battlefield. Unlike Windows, which uses various drive letters like C or D, Linux relies on a unified directory tree, and it all starts from a single point, the root, which is represented by a simple /. Every single branch descending from that root serves a highly specific critical purpose. For example, the /home directory is the dedicated space for regular user accounts. The /etc directory? Massive for security because it holds system-wide configuration files. If an attacker wants to steal user password hashes, they're hunting in /etc. And /var houses variable data, most notably your system logs. So if a defender is trying to figure out exactly how an attacker got in, they're frantically reading the logs in /var. Knowing this terrain is totally non-negotiable. And of course, to navigate this digital terrain, you've got to speak the language of the terminal. These are your fundamental movement tools. You use pwd to print your working directory so you never get lost in the dark. ls lists out the files in your current folder. cd allows you to change directories and move around the tree. makedir creates new folders, and rm removes files. But hey, a word of intense caution on rm. There is no recycle bin in the Linux terminal to save you from a mistake. Once a file is found, it is gone for good. Which brings us to Module 4, Locking Down User Permissions. If there is an absolute golden rule of information security, it's the principle of least privilege, or PULP. This means granting users only the absolute minimum permissions they need to perform their specific tasks and nothing more. You never ever work out of the root superuser account unless it's absolutely necessary. In enterprise security today, this single concept anchors the entire permission framework we're looking at. A failure to enforce this principle is exactly how minor breaches snowball into full-scale, company-ending network takeovers.
To practically enforce that principle, we use what I like to call the 2-second numeric permission decoder ring. Every single file and folder in Linux is governed by 3 ownership categories: the owner, the group, and others. And you can assign precise permissions to these categories using some really simple math. Read permission is assigned a value of 4, write permission gets a 2, and execute permission is worth 1. You simply add these numbers up. So if you want a user to have full read, write, and execute access, that's 4 plus 2 plus 1, which equals 7.
So the crucial point here is how this simple math translates instantly to real-world high-stakes security. A permission setting of 777 means the owner, the group, and literally anyone else on the machine has full read, write, and execute access. Setting a file to 777 in a production environment is the digital equivalent of leaving your company's front door wide open in a bad neighborhood. Compare that to 644, a standard public document where only the owner can write to it but everyone else can read it. Or take 600, which is ultra-secure. Only the direct owner can view or edit the file. It is completely invisible and locked away from everyone else on the system. To actually apply this security math to your files, you need your heavy iron padlocks and your keycards. In Linux, those are chmod and chown. Chmod changes the numeric permissions. For example, typing chmod 600 on a highly sensitive file snaps that heavy padlock shut immediately. And chown acts as your keycard system. It lets you change the actual ownership of a file to a specific user and group context. Together, these tools give you the precise, granular power to perfectly enforce that principle of least privilege across millions of files.
Okay, Module 5, your cyber sandbox, Kali.
To practice cybersecurity legally and, most importantly, safely, professionals build virtual machines, which are essentially computers running completely isolated inside your host computer. Think of it like building an armored blast chamber where malware and exploits can be detonated safely without burning down your actual laptop. And setting up this blast chamber is incredibly accessible. First, download the official Kali Linux ISO image. Second, install virtualization software like VirtualBox. Third, spin up a new virtual machine, allocating it a chunk of your RAM and storage. And finally, run the initial configurations and updates. Once you boot up that Kali sandbox, you'll be greeted by a graphical interface. But honestly, you'll quickly want to ignore that and open the terminal. While graphical interfaces are pretty, real cyber warfare happens exclusively in the raw text of the command line. It's blistering fast, it's highly scriptable, and it allows you to chain complex networking tools directly from the keyboard without a mouse slowing you down. Mastering this raw text environment is basically your rite of passage.
And finally, Module 6, Active Network Reconnaissance.
Before a single digital shot is fired, security professionals always gather intel. Using your new Kali sandbox, you can leverage built-in info-gathering commands to map out your targets. Think of tools like NSLOOKUP and DIG as digital binoculars used to case a joint from afar. Whois pulls up domain ownership and organizational contact info. NSLOOKUP quickly finds the exact IP address associated with a domain name. And for the really deep dives, DIG allows you to perform advanced DNS queries, showing you exactly how target traffic is being routed behind the scenes, all before you ever actually touch their network. Once you've mapped the target from afar, you can move into live-fire analysis. The ping command lets you test basic connectivity and verify if a host is currently alive and responding. But the real magic happens when you use tools like tshark or TCP dump. By pointing these tools at your virtual network interface, you're essentially putting on network X-ray glasses. You can suddenly capture and read live invisible packets flowing across the network in real time. It reveals this hidden matrix of data floating right in front of you. Combine that with Nmap to scan for open ports and vulnerable services, and you suddenly possess a complete, real-time map of a target's entire digital footprint. So, we've covered the foundation, the crucial file systems, the strict math of permissions, and the powerful reconnaissance tools that hackers and defenders wield every single day. But as we wrap up, I want to leave you with this final, vital question to think about. If an attacker manages to exploit a vulnerability, and they compromise your operating system at its root level, can you truly trust anything else on your machine ever again? The OS is your absolute foundation of trust. Keep exploring, keep building those blast chamber sandboxes, and never stop questioning just how secure your foundation really is.